In our previous lesson, we were left with some intriguing questions, right? What if we keep the magnet stationary and move the coil towards and away from the magnet? Will there be any current induced? And what all are the factors which affect the strength of the induced current? Let's try to find the answers to these questions. First, let's move the coil which is connected with the galvanometer towards and away from the magnet. What do you notice? The galvanometer is getting deflected, which means by moving the coil towards and away from the magnet, current is getting induced in the coil. Why did this happen? The answer is something we saw in the earlier part. It happened because there is a change in the magnetic lines of force. But where? When we move the coil towards and away from the magnet, the magnetic lines of force passing through the coil change, and hence the current is induced in the coil. So whether we move the magnet towards the coil or the coil towards the magnet, current will be induced. It's called relative motion. Now let's find out the factors on which the strength of the induced current depends. Just observe what I will be doing now. I'm going to move this magnet towards and away from the coil slowly. The galvanometer deflection is not much, right? Yes, it means less current is induced. Now let me move the magnet really fast towards and away from the coil. From the rapid galvanometer deflection, we can say that the current induced got increased. So we can say that the speed of the relative motion between the coil and the magnet is a factor on which the strength of the induced current depends. Now what do you think? Is there any other factor on which the strength of induced current depends? I want you to think of the answer. When the speed is increased, the strength of the induced current got increased. But when we increase the speed of what? The magnet, right? Did you get the hint? That's right. If the magnet is stronger, then more current will be induced. So two of the factors are speed of relative motion and strength of the magnet. Is there any other factor which affects the strength of the induced current? Yes, if we increase the number of turns of the coil, then the strength of the induced current will be more. So what can we conclude? We can conclude that the factors on which the strength of induced current depend are the speed of relative motion between the magnet and the coil, the strength of the magnet, and the number of turns of the coil. But now I have a question for you to think. What if I replace the permanent magnet with a temporary one? Will current get induced in the coil? To find out the answer to this question, move on to our next video.